So we are starting section 6.1, operations with polynomials. Our objective for today is to simplify monomials and expressions involving powers. Let's review some vocabulary. The first word we're going to review is simplify. In today's case and for the future cases of this unit, we are going to be rewriting expressions without parentheses or negative exponents. The degree, if you recall from last week, the degree of a polynomial is the degree of the monomial with the greatest degree. So again, it's not the degree of all the terms added together, it is the degree of the monomial term with the greatest degree. A to the b is known as an exponential power, where a is the base and b is what we call the power or exponent. So we have a couple properties of exponents that we're going to be using. You're probably going to need to pause the slide to fill in your table because I'm not going to walk through every one. But the product of powers says that if you have the same variable being multiplied together, that you add the exponents. The quotient of powers says that if you have the same variable being divided, you subtract. If you have a negative exponent, you rewrite it so it's in the denominator as a positive, or if it's in the denominator, you bring it up to be a positive. A power to a power, so if you have x to the a in parentheses raised to the b, we multiply. And if you have a power of a product, meaning you have a power outside your parentheses, then that power distributes to every term inside, whether they're being multiplied or divided or both. And then just a simple review, anything to the 0 power is always 1 except for 0. So anything to the 0 power is 1 except for 0. There are a few simple things we can do to check to make sure our monomials are simplified. You want to make sure you have no powers to powers. You want to make sure that each base appears exactly once, meaning you don't have an x in the numerator and the denominator. You want to make sure all fractions are simplified. So if I had something like 12/15, that would reduce because both terms divide by 3. So 12/15 would become 4/5. And then you also want to make sure you do not have any negative exponents. So what we're going to do now is simplify some expressions. So we have a to the negative 3, a squared, b to the 4th, c to the negative 1. So what I'll notice is I have two negative exponents and I have two a terms. So the first thing we're going to do is group the a terms together. So that gives you a to the negative 3 plus 2, because if they have the same base and they're multiplied, you add the exponents. So negative 3 plus 2 is negative 1. So you get a to the negative 1, b to the 4th, all over c, because what we did was take the negative exponent on c and drop that down to the denominator as a positive. And that's the last thing we're going to do here with the a. Since a is to the negative 1, we're going to drop it down to be multiplied by the c as a positive. N squared over n to the 10th. So again, we have the same base. We have a base of n, and we have the power of 2 and a power of 10. So if you're dividing, the rule is to subtract the bottom from the top. So it'd become n squared minus 10, which becomes n to the negative 8th. We don't like negative exponents, so the final thing is to drop that down as a positive. So you get 1 over n to the 8th. This is a product of powers as well as a division of powers. So we have 3a cubed all raised to the second, as well as b to the fourth raised to the second. So what we're going to do is distribute that squared term to each term inside. So that gives me 3 squared, a cubed times 2, b to the fourth times 2. So we're going to multiply our 3 times 2 and our 4 times 2, as well as square our 3. So we get 9a to the 6th, b to the 8th. Similar example, we're going to take that squared term and distribute it to each of the terms inside. So you get 6 squared, r squared times 2, 3 squared, s cubed times 2. And then when I distribute that, it actually would get rid of. So that would create 36 r to the fourth, 9s to the 6th. But again, we need to simplify our fractions. So 36 divided by 9 would give you 4 r to the fourth, s to the 6th. So is it a polynomial? We talked last week briefly about is it a polynomial? Let's just review that because that's something that's going to keep coming up. A polynomial cannot have division by another variable. It cannot have square roots. And it also cannot be a fraction where we have a negative exponent. The degree is always the highest monomial term in the polynomial function, not the sum of the terms. So, is it a polynomial? We're going to determine whether this is. So right here where we have this term negative 4 square root c, that square root makes it not a polynomial. Okay, here we want to determine if this one's a polynomial. Polynomials can have multiplication of the same or different variables. They can have fractions that are numerical. So the answer is yes, this is a polynomial. The degree of the polynomial is the sum of the two terms being multiplied together. So this first term here has a degree of 3, but the second term has a degree of 9. Therefore, the polynomial has a degree of 9. Okay, we have x squared minus 3x to the negative 1 plus 7. This is not a polynomial, because the 3x to the negative 1 is really like 3 over x. So we can't divide by x, therefore not a polynomial. That is all for today. Thank you, and hopefully you are able to complete the Khan Academy practice.